Hey, we're back here with the last section of Chapter 7. Got to be excited about that. And if you're watching this, that means the chapter test is right around the corner. So make sure we're getting that homework done, asking questions in class, and all that, so we're ready to go. Chapter 7, Section 6, multiplying a polynomial and a polynomial. Okay? The common term for this process is called to FOIL, F-O-I-L, foiling. When you're multiplying two polynomials together, whether they're binomials, trinomials, no matter how many nomials are there, it's called foiling. Okay? And that comes from the acronym first out, U-T, inner, and last. Okay? I'm not going to go into the details of where those came from because I think that process is very laborious, meaning it's time consuming and it's not going to be very beneficial to you. But just know that the name FOIL is the name for multiplying two polynomials. Foiling, the first, outer, inner, last, is the process that you can do just two binomials with. But since we're going to be doing more than just binomials, we're also going to be doing trinomials. I don't want to take the time to teach you the actual FOIL process because the other two methods that we're going to talk about work for both binomials, trinomials, four-term nomials, however many nomials you have. Okay? So here's the two ways that we're going to do it. The first method is what I call the claw method. Okay? The reason I call it the claw method is because when you draw the arrows showing where stuff's going to go, it makes a claw. Okay? So what happens is I take this first term, the x, and I distribute it to both terms in the second polynomial. Looks kind of like the distributive property. I then take my second term 2 and distribute it to both terms in the second polynomial. And you can see it sort of makes a crab claw looking thing, which is why I call it the claw method. Okay? So if we can follow along here, we did x times x to get x squared. We'll use some different colors on these lines to help coordinate this. Then I can do x times 3 to get a positive 3x. Then I can do 2 times x to get a plus 2x. And the last step is 2 times 3 to get plus 6. Okay? Then I have to check to see if there's any like terms that I have. I only have 1x squared, so I bring that down. I have a 3x and a 2x that I can add together to get 5x, and then I have a 6, one constant. So that's my final answer, x squared plus 5x plus 6. Okay? Not terribly difficult. A binomial times a binomial is just a simple distributive property. So let's take it up a little bit. Let's try a binomial times a trinomial, 2 times a 3. Okay. So again, I'm going to take my x, distribute it to all 3 terms. Then I'll take my 8 and distribute that to all 3 terms. You can see it still kind of looks like a 3-dimensional claw this time, if you look at it the right way, at the right angle. So that's why I like the name the claw method. All right, so x times x squared gives me x cubed. X times 4x is a plus 4x squared. And x times negative 3 is minus 3x. Then I do the bottom. 8 times x squared plus 8x squared. 8 times 4x plus 32x. And the last one is 8 times negative 3, which is negative 24. Now the tricky part, going through and finding all your like terms. Okay, this is where I like to cross stuff out so I make sure that I get everything. Start with x cubed. I don't have any others. When I look at squareds, I have a 4x squared and an 8x squared. If I add those together, I get 12x squared. You'll see this is just adding polynomials. Okay? We did that 2 sections ago, so hopefully you didn't forget that. Next I have a minus 3x and a plus 32x, which gives me a plus 29x. And finally, I have a minus 24. If everything is crossed out up top, then I know I'm done. Okay? So that's the claw method. You will be happy to know that we're not going to do any trinomials times trinomials. I gave you one at the bottom and the back to try for fun if you want to. Some of you looking for a challenge or might be bored. But we're not going to do any in class for homework or on the tests. Okay? Someday you'll have to in high school math, but not for me here. So here's the other method that we can use. So you're either going to use the claw or the chart, are the two ways. You're going to pick one or the other. You notice it's the exact same problems. Okay? So at least watch this and then decide which one you like better. The chart is going to take the first polynomial, and you're going to be creating like a times table. Okay? So something like this. The chart is going to take the first polynomial and put it up top. So I have an x and a positive 2. Then it's going to take the second polynomial and put it on the side, x and a positive 3. Then inside, you're just going to multiply them. X times x, x squared. X times 2, 2x. 3 times x is 3x, and 3 times 2 is 6. Then if we pull them out, we'll pull out x squared. We see right here, 2x and 3x are the same term. I can add those together to get 5x. Then I also have a plus 6. And if you turn over your paper and take a look, you can see x squared plus 5x plus 6. And if I look at the claw method, x squared plus 5x plus 6. Okay? Second example, a binomial times a trinomial with the chart. Okay. Let's go ahead and make our chart here. This time, the first polynomial is a binomial. The second polynomial is a trinomial, so we're going to need a little bit extra room here. Okay, so let's take the first polynomial and put it up top, x plus 8. The second polynomial and put it on the side, x squared plus 4x and minus 3. Don't forget your negative. Now we're going to do the same thing. X squared times x, x cubed. X squared times 8, 8x squared. 4x times x gives me a 4x squared. 4x times 8 is 32x. Negative 3 times x, negative 3x. And negative 3 times 8 is negative 24. Okay? Again, we can now pull stuff out. X cubed can come out. Like terms here, 8x squared and a 4x squared give me plus 12x squared. Right here I have like terms, 32 and minus 3x. You get a plus 29x and then a minus 24. All right, so there's our final answer. And again, if we turn over to the front, you'll see that that's the same answer that the claw method got us. X cubed plus 12x squared plus 29x minus 24. Okay? So I hope you like one of those two methods. I suggest picking one, maybe trying both of them for the first 2 or 3 homework assignments or homework problems, then picking one or the other. Okay? Personally, I prefer the claw method, but I know several people who prefer doing the chart because it keeps a nice ordered fashion. Okay? So pick your favorite and go to it. Now, the problem at the bottom, if you don't care about this problem at all because it's not going to be on any tests or quizzes or anything, go ahead and stop. But if you are curious, I would pause this, try it yourself, and then check your answer to see if you got it. Okay? So I'm going to go through it real quick here. I first take my x squared, and I have to distribute that to all 3 terms. So that's going to give me negative 3 x to the 4th plus x cubed minus 4x squared. Then I take the minus 2x and distribute that to all three terms, which is going to give me plus 6x cubed minus 2x squared plus 8x. Then finally, I take the 5 to all three terms, which gives me minus 15, where am I at? X squared plus 5x and minus 20. Now we go through, find all of our like terms. I know that 4 is only used once, so that's a minus 3x to the 4th. I have an x cubed, 6 more x cubes, and it looks like that's it. So that gives me plus 7x cubes. Then I have minus 4x squared, minus 2x squared, and minus 15x squared. So that comes out to minus 21x squared. Then if I look at my x's, I have 8x and 5x, which are 13x, yes, plus 13x. And the last I have on minus 20 at the end. So here is our new polynomial. When you do those two trinomials, I get negative 3x to the 4th plus 7x cubed minus 21x squared plus 13x minus 20. All right. Hope you got it if you stayed to try it. And we'll see you guys in class. Good luck on your test, by the way. Whoa, sorry. Good luck on your test, by the way, coming up here. This is the last chapter. So good luck, and we'll see you later in chapter 8. Bye.